Fourth part in March is a booster. Why do you need a booster? Well, basically it provides more current. So if you have a big model railway layout with lots of tracks and lots of trains, the base station may not be able to drive all of it. So you can break it up into sections and have each section driven by a booster, but it all still works as one system. So basically the booster just increases the amount of power and current that can be delivered to the system. Here's the circuit diagram. It's similar to our base station. It's basically a cut down base station. You can see the circuit board here. It's a bit smaller. There's no screen, etc. It has the socket for control. And you can have, as I said, you can have several of these on a layout. You might only need one. You might not need a booster at all. But if you do, it's a pretty straightforward thing to build. Again, there's a kit. Here we talk about how you can connect the booster. It's a little bit tricky because, well, actually this booster can, as it says here on the front, it's also a reverse loop controller. And so you can see in this example here, when you have a loop, there's a bit of a problem that if you just had a complete loop, it would create a short circuit. You'd be shorting out the two tracks. So what you have to do for a loop is have breaks here. And the trick is that the loop part, as a train moves from the track onto the loop, it needs to be driven in one polarity, and then as it moves off, it needs to be driven in the other polarity. So this will automatically swap the polarity of the loop as the train goes around by sensing the current on the tracks. So that it's a seamless, you don't notice the swapping, it just happens. So as long as you only have, you can't have trains going in and out at the same time. That's really the only limitation. And it's the same thing with this T here, that you need the same thing. So the booster can do that as well. You don't need a separate device. Here are some photos of it. Again, the case cutting, assembly details, screen displays. And so then we move on to the fifth part, which is this stepper motor driver. Now you might wonder, well, why do you need a stepper motor driver in a railway layout? Well, there are two reasons we did this. One is that sometimes it might be attractive to use a stepper motor to drive a small model train, but it's not easy to do because a stepper motor isn't something you just apply voltage to and it spins. You actually need to control it. So this is effectively a DCC decoder that has the logic needed to drive a stepper motor. There's another reason, which is that this can be used outside of a model railway system simply as a stepper motor driver. And it's quite a clever one in the sense that it kind of makes a stepper motor act like a regular DC motor. So you apply a voltage to this board, and the higher the voltage you apply, the faster it will cause the motor to spin. But it does that by actually varying the rate at which it sends steps. So it can be used in model railway, or it can be used separately. But it's basically an alternative decoder. And then in May 2026, this year, we followed it with this micro DCC decoder. So this is a cut down decoder. It's even smaller. It's intended for particularly small trains, but it could be used in bigger ones. There's no reason it couldn't. The only real disadvantage is that it only has 2 accessory outputs rather than 4. But in many cases, that's all you need because that still gives you forward and reverse lights. And there's another feature, which is that this one actually has a built-in sound output, unlike the main decoder. So we've used a chip with enough memory that you can store either a bell sound or a whistle sound, and you can remotely trigger it, and you can also have it repeat. All you need to do is connect a piezo buzzer, and it's done through this same header that's used for programming. So again, we have a kit for this. The kit comes with the buzzer. So this gives you a small decoder with sound on board that has 2 accessory outputs. Here are the assembly diagrams. It's similar to the other decoder, it's just shorter. So it might be better for fitting into smaller places. Then in July this year, we've added these 2 accessory decoders. So these are basically for stationary use. If you have points is the main application. So points is where you have a track that can switch between 2 tracks. So these can drive those points to switch under the control of DCC. So you can use the same base station and the same system. You don't need to run extra wires. The tracks provide power and control for the points. The reason there are 2 kinds is that there are different kind of points. So there's what we call the snap type here. And this drives a solenoid to basically a linear motor that flicks the points from one direction to another. And this uses a capacitor to store the charge that's needed to drive that, because there's a fairly high current demand for a short period. Then there's a servo version. This has 4 outputs to suit 4 servos, and it can basically switch the servos between 2 different positions. So this can be used for points that have servo motors. It can also be used for things like semaphores, which is basically like a flag arm that moves up and down to tell a train whether it can go or stop. And this will drive that. And you could even use it to do things like drive level crossing lights, stuff like that. So it's just a generic servo driver that can drive up to 4 servos controlled by DCC. And by the way, the snap type over here that I talked about using to drive a solenoid, It can also just drive independent load, so you could have 4 LEDs and you could just switch them on and off using this same board. It's quite flexible. And this is about to get to this. This can be used to control and program the decoder. With the regular decoder, you can just put the train on the programming track and program it. But this board is stationary, it's fixed in the layout, you can't really do that. So we have this small extra board that can plug into it that can do things like change its address and also just switch the outputs on and off. In fact, you don't even need a DCC system to use this. You could just permanently attach this controller and just use the buttons and screen to control it. This shows how you can connect 4 servos to the servo board. We have some diagrams showing here how the snap type can be connected to different kinds of motors and loads. Here's the parts list. Again, we have kits for both of these. And then in the same issue, we had this I2C controller. Now, this is a very simple device, as you can see from the circuit here. It's basically an OLED screen and an I2C expander that connects to 4 buttons and a bicolor LED. So you plug it into the decoder can display information on the screen. You can see here, such as some of the settings, and you can use the buttons to change the settings. But really, this could be used for other projects. It's just a screen and some buttons. So anywhere that you need a screen and some buttons, and you're happy to communicate with them over I2C, you could use this board. We may well use it in future for other projects. But in this particular instance, it's designed for use with those 2 accessory decoder boards. And you can see here we show how it connects. Again, there's a kit. It's relatively inexpensive because there's not a lot to it. And then in the latest issue, just being published now, the August issue of Silicon Chip magazine, we have this model headboard destination display. So this is a small screen. You can either put it inside a locomotive or in a stationary sign or something like that. This here shows a real train that has a sign. So you can see you can fit it to the front of a train and have a little window so you can see the sign, and it can do things like show where the train is going. To do this, we've had to find some very small OLED screens. Here's some diagrams of them. You can see that there's not much to the circuit. Again, we've kept it simple. There's a microcontroller. It is not directly DCC controlled, but it can interface with our DCC decoder. So you can connect this to the decoder as we've done here and remotely through the DCC system change what's shown on the screen. There's also an EEPROM here that stores the display data, and it has NFC, so you can use NFC to update that data wirelessly, which means you could update the train without even having to open it up. And you can do that with a device like a smartphone. We explain how to do it. And then this header over here is where the screen connects, and it has the support components. So we have some pictures here. You can see the back of the board that has the chips and the capacitors and so on. The front is basically just the screen, which attaches by a flex cable. And then we show a couple of options here for the RFID antenna for updating the data, either a flex PCB or just a loop of enamel copper wire. Here's the parts list. Again, there's a kit. The screen is not included in the kit because there are multiple different screens that can be used. We have 2, so you can order the screen that you want along with the kit. Oh, and by the way, I mentioned that this can be controlled by DCC. It can also be controlled by an infrared remote control. So you could or arrange that. You can have a receiver in the train and you can just point a remote at it and press a button and have it change the display. This here shows how to wire it to the DCC decoder or DCC control or the infrared receiver. And we have some software here for creating the display. We also give some examples. You could just use our sample display if you want to, which is, you can see some of it there. And then we talk about how to upload the data, what the format is, and how it works. So here are the smartphone screens showing us loading data into it and changing the parameters. That lets you make your model railway very realistic. You can have trains running around that show supposedly where they're going on the screen, and you can change that at will. And you could also have signs in the stations showing things like schedules that you could change. So that's the end of our DCC series for the moment. There are 10 articles in the series, and it finishes in this August issue that's just going on sale now. But there may well be more. If we can come up with more, we'll publish it eventually. And we have some ideas, but there's nothing concrete at the moment. Well, I hope you found that interesting. I think even if you're not really into model railway, there are quite a few aspects of this that could be food for thought, or maybe give you ideas for your own projects. And if you are into model railway, hopefully this is something that you can use. I think DCC is probably the best way to go these days if you do want to have a model railway layout, because it gives you maximum flexibility. You can have multiple different trains, multiple different crossings, points, displays, lights, and just control them all from from one place. In fact, you can even control them from a computer. Some people do that. There's free software to do that. So yes, check out Silicon Chip Magazine from December 2025 to August 2026 for all these model railway projects. Thank you.